Hey guys, welcome back to my YouTube channel Whisk and Wisdom. It is wonderful to be back in the kitchen lab with you. Today we are diving straight into the fascinating kitchen lab to uncover the delicious chemistry and physics that turn everyday ingredient into culinary masterpiece. Throughout my time in luxury hotels, I have learned that secret to a signature bake lies in the science of aeration. We as chefs are not just preparing meals, we are conducting experiments. Today, we are discussing the rising stars of your pantry that help you transform a dense mass of flour into the light, airy texture that define world class patisserie. We are talking about leavening agents. Whether you are in a professional kitchen or at home, understanding how these work is the difference between a mediocre and a masterpiece. Simply put, leavening agents are the ingredients or methods we use to introduce aeration into a product during preparation. This intentional production of gas, trapped by the gluten or egg protein, expands under the heat to give us volume, tender texture, and better flavor. To achieve this, we manipulate three primary gases: carbon dioxide, produced by yeast and chemical reaction; steam, it is generated when moisture in our dough hits high oven temperature; oxygen, which we physically whip into our mixture. Leavening is about so much more than just height. It dictates the entire sensory experience of your product. For example, a sourdough bread. It has a beautiful open crumb texture because of long, slow gas production. A brioche, on the other hand, is incredibly tender, as the leavening creates millions of tiny, uniform bubbles for a soft mouthfeel. A croissant, very differently, relies on steam to physically push layers of dough apart, creating that signature flakiness and honeycomb texture. Now that we understand what leavening is, we need to look at a toolkit. In a professional kitchen, we don't just mix things together and cross our fingers for the magic. We choose a specific method based on the final result we want. To do this, we categorize leavening agent into three distinct pillars: biological leavening agents, chemical leavening agents, and physical or mechanical leavening agents. Now, let's talk about a very first biological leavening agent. It is the oldest form of leavening. It is a fermentation process where a living organism consumes sugar to produce carbon dioxide and alcohol. It requires time and temperature control. It's all about managing a living ecosystem. We are primarily talking about commercial yeast and wild sourdough culture. This is a slow and steady approach as it deals with the biological process. We are not just looking for a lift but for active fermentation. During the process of fermentation, yeast breaks down the sugar into carbon dioxide and alcohol, but it also produces organic acid and ester, which create that slightly sweet aroma and signature yeasty nutty flavor we find in our artisanal breads. Chemical leavening agent. This category consists of baking powder, baking soda, that is your sodium bicarbonate, and ammonium bicarbonate. These relies on precise acid base reaction. This pillar is defined by immediacy and precision. We use these when we want tender texture and immediate carbon dioxide production. If you've ever had a cake fail, it is often because of acid base here was off. Now, mechanical or physical leavening agent. The act of physically introducing air into a batter or a dough to increase its volume and lighten up its density is known as mechanical or physical leavening. Unlike biological or chemical leaveners, this doesn't rely on additional ingredients to produce gas. Instead, it relies on the chef's technique to trap atmospheric air or moisture. Creaming butter and sugar, sifting flour, rubbing fat into the flour, and beating egg white. These are all mechanical techniques used as leavener. The air bubbles we trap expand in the oven, combined with the steam, force a pastry to rise. As this topic is too massive, I have broken this masterclass down into the four clear objectives to truly understand the why behind the rise. Understanding the three pillars. We need to categorize every leavening agent into those three buckets: biological, chemical, or mechanical. If you can't categorize it, you can't control it. Mastering biological versus chemical reaction. In our upcoming videos, we will learn exactly why yeast needs that time and warmth, while chemical agent demands precision and speed. The physics of steam and air. Now, this is where the magic happens in items like puff pastry and delicate sponge cakes. We will discuss how to use heat and motion as physical tools for volume. Professional troubleshooting. This is the most practical and honestly my favorite part. In the upcoming videos, I'm going to give you bakery forensic skills. You will learn to look at a failed product, identify exactly which reaction went wrong, and know how to fix it for the next batch. So there you have it, the foundation of leavening. By the end of the series of The Science of Rise, you won't just be following a recipe, you will be engineering a perfect result every single time. Make sure you hit the subscribe button, press the bell icon, because in our next video we'll be diving deep into the fascinating world of biological leavening, where we will unlock the secret of yeast and sourdough cultures. Thank you so much for joining me in. Get there, start experimenting, and I'll see you right here in the next video.